HCF is 24. Okay, leaving your answer as 2 to the power of 3 times 3 will not give you any marks. You have to look carefully at the question. They want an integer. So give me the integer. But if the question says, find the largest integer, which is a factor, blah blah blah, leave in index notation, then this will be the answer. Okay? So it depends on what the question wants. Next part. Find the smallest possible integer of p such that r multiplied by p gives us a multiple of 75. Go take up paper quickly. So in order to do this very common type of question, what we're actually looking for is the LCM. Okay? So first we write down the LCM of 75 and r. So the LCM of 75 and r is actually this. If you are able to write the HCF, I don't think you should have a problem writing the LCM. So after writing the LCM, this is going to be equal to RP. Okay? The LCM is actually going to be RP. And we're going to compare this with R. What does R look like? 2 power 5, 3, 7 power 2. R equals 2 power 5 times 3 times 7 power 2. Now if what I have just circled is R times P, and R is given to be 2 power 5 times 3 times 7 power 2, then we only have a missing 5 squared. This is going to be our value for P. We're doing a comparison. So this is one way to do it, by comparing the LCM. I got a feeling this will come out. Again. Mia. But there's another paper that somebody else said. So there are 2 papers. I got a feeling that this will come out. So you better know how to do this. Look through your notes. Every time this type of question comes out, make sure you know how to do it. Can I move on? Okay, so now we are at graph question. So now over here we've got A, B, C, and D. My graph over here is not drawn very well. I think some of them actually shifted. Can I see your original question? Okay. So this is what you all have. A, B, D, and C. So this is our Y, X, and 0. Thank you. So what we are told to do is to draw Y equals to 6. So this Y over here refers to a level. Level 6. Draw level 6. Level 6 is horizontal. Y equals to 6 is a horizontal line. Where exactly is level 6? Well, I only know that this is level 0. Then A itself has a coordinate of 1, 1. Okay, this is 1 and this is 1. B has coordinates of 6, 1. Okay, A and B, they are both on level 1. So we continue to do so, and D is at block 1, level 6. Point C is at block 6, level 6. So I now am very sure that my level 6, in other words, my graph of Y equals to 6 looks like this. Okay, one horizontal line passing through D and C. And you must label. This is for part 1. Y equals to 6. So the next question is X equals to 1. They want you to draw block 1. Block 1 over here. A vertical line passing through A and D. So this is for part 2. X equals to 1. So draw the lines. These are the 2 lines you have to draw. Can I move on? So 1 mark each for this. Oh, then they go on to say that ABDE is a parallelogram. ABDE is a parallelogram. State the coordinates of point E. Okay. Let's start joining the points. A to B. Then to D. A, B, D. And another point E, such that it will give me a parallelogram. So you're supposed to find a point. Let's do a quick check. Are you able to visualize roughly where point E is? Can you roughly tell where it is to form a parallelogram? If point E is here, does it look like a parallelogram? Doesn't, right? Totally doesn't look like a parallelogram. If it is over here, does it look like a parallelogram? Also doesn't. How about somewhere here? Can? Looks more reasonable, right? Because a parallelogram will have opposite sides that are parallel. And they are of the same length. That's what makes it a parallelogram. So if this is point E, then I can join E with A, and I will also obtain EA parallel to DB, and they have the same length also. Okay, now that I managed to show you where point E is, what are the coordinates? What is the block? What is the level? Which is easier, the block or the level? For point E, block or level, which one is easier? Level, right? It is level 6. It has a y coordinate of 6. It is something, comma 6. But what block is it? Negative what? Why negative 6? What exactly are you using to determine the block over here? We have to consider that they are the same length, right? AB, ED, same length. What is the length of AB? Look closely. What's the length of AB? 5 or 6? 5. 5 units. Which means that from here to here, this will also be 5 units, right? E to D also 5 units. Well, point D is at block 1. If I move 5 units over here, 1, 2, 3, 4, 5. What will I get? Negative what? Negative 4. This is negative 1, negative 2, negative 3, and negative 4. So it is a block negative 4. So we do a check. Oh, what is the length from block negative 4 to block 1? It is total of 5 units, which corresponds to this also, 5 units. Okay, so be careful over here. Negative 4, 6. Those are the coordinates of point E. So presentation-wise, either you write it like this, or you can say E has the coordinates of negative 4, 6. This will not be accepted. Not accepted. Okay, if you flip them around, you get E to be 6, negative 4. This is definitely wrong. Because it's the wrong address, wrong block, wrong level already. Okay, question 11. So here, one of the interior angles of an octagon. How many sides? 8. Confirm? But I thought October is number 10. October's 8 legs, right? Did I tell you about the word, the root word for this before? OCT. Did I tell you before? How come the October refers to the 10th month, but the word octopus has 8 legs. Then our octagon has 8 sides. Something looks wrong, right? Which one went wrong? Which one is wrong? October, right? This is the odd one out, isn't it? How about DEC? DEC, ADE, what does it refer to? 10 years, right? How about decagon? 10 sides, right? Is there something that is funny, that is weird? December, right? What about this? 12. 12 month. Why the months also weird one? Yeah, why? But why? Why didn't they use December as month number 10? There is some history behind it on the naming of the months. I think last time they only had 10 months. I think so only. Then somehow they added 2 more months, then they changed the name, blah blah blah. So actually by right, October was supposed to be the 8th month. Supposed to be, but there were some changes along the way. I don't know which month they added. Okay, but actually they have meaning in all these names over here. So turns out that students last year, they thought that an octagon was 10-sided. Okay, so please don't make this mistake. This is 8-sided. So 8 of them, one of them has an angle of 4x plus 8. Another 2 of them, 3x plus 46. And the remaining angles, how many remaining angles are there? How many? 5? Because we got total 8, we used up 1, we used up 2, over here, 5 left. So 5 of them are 3x. So if you draw 1, 2, 3, 4, 5, 6, 7, 8, this could be 4x plus 8, this could be 3x plus 46, 3x plus 46, and the rest are all 3x. So that's the situation over here. Find the value of the smallest exterior angle. Before we get to doing that, I'm sure we need to find the sum of the interior angles. So we obtain that by the formula, 8 minus 2. So for an 8-sided figure, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, I can split it into 6 triangles. So 6 times 180 degrees, this is the total 1080. Apparently, if we add all of them up, 4x plus 8, that's one of the angle, 2 of 3x plus 46, and 5 of 3x. You're supposed to get 1080. So you go and expand, simplify, you get x equals to 39.2 degrees. Okay, turns out in this case we don't have an integer as the value of x, but it's okay. X can be 39.2. No problem with that. But that's not the end. They are not asking you to find x. They want the smallest exterior angle. So what does an exterior angle look like? If this is my diagram, with this as the interior angle, then this is the exterior angle. I want the smallest exterior angle. The smallest exterior angle will correspond to the biggest interior angle. I need to find the biggest interior angle. Then I subtract the biggest interior from 180. That's how I get my smallest exterior angle. Okay, so the smallest exterior angle will be 180 minus this is the largest interior angle. Can? Oh, yeah, so remember this problem that I told you when I first taught you exterior angle? Some students still thought that the exterior angle, if this is the interior angle, some students still thought that this is the exterior angle. This is wrong. Okay, so you cannot use angles at a point for this. The exterior angle is obtained by drawing a straight line. This is the exterior angle. Instead of drawing this, line over here, we could have drawn this line also. This is the same exterior angle. Do you know how to prove that these two are the same? Do you know how to prove that these two are the same? What is the property? Vertically opposite angles. They are the same. No matter how you draw the straight line. No matter whether you extend it this way to get this angle, or you extend it this way to get this angle, they are the same. Samuel, do you have a question? Okay, next. Wow. 1 over x equals to blah blah blah. Give you some values. Find the exact value of x. They gave you a, they gave you k, they gave you h. Let's do a substitution. So it's sub. You get 1 over x equals to this. Anybody got this stage? Until this stage? Then after that, how do you find x? How come reverse will work? So apparently many students manage to get 1 over x, but then they don't know how to continue. Okay, so let's think about it. If I tell you that 1 over x is equal to 1 over 2, what is x equal to? What's x equal to in this case? Is it obvious to you? Has to be, right? 1 over x is 1 over 2, so x is equal to 2. Okay, what about 1 over x is equal to 1 over 5? What is x equal to? 5. Simple. What if it is no longer 1 over here? What if this is 2? Then let's say this is 4. What is x equal to? If 1 over x is equal to 2 over 4, what's x equal to? How do you get 2? Because 2 over 4 is 1 over 2, right? Then you get back the same thing, and then you can therefore tell me that x is equal to 2. We can play around with the fractions like this. Okay? The other way is, what if we cannot simplify the 2 over 4? Okay. I think my stylus is out of battery. Okay, what if it looks like this? 3 over 7. Then what is x equal to? So one thing that we have learned actually is to be able to do this. Remember? So based on this, we have 3x equals to 7. And then what is x? 7 over 3. So this is something that you can do. But is there a faster way? Is there a faster way? Let me just list out all the other examples that I've shown you so far. So if 1 over x is 3 over 7, x is 7 over 3. I also showed you 1 over x equals to 1 over 2. That means x equals to 2. If 1 over x equals to 1 over 5, that means x equals to 5. Okay, now look at these 3 examples. Is there a shortcut? Is there a 1 second answer to tell me the value of x? And I give you a small clue. 2 over 1. This is 5 over 1. What do you notice? If 1 over x is 1 over 2, then x is flip 2 over 1, which is 2. If 1 over x is 1 over 5, x is flip it around, 5 over 1, which is 5. If 1 over x is 3 over 7, x is flip it around, you get 7 over 3. So same over here. If 1 over x is 539 over 529, then x is flip it around. And you get the answer. Okay, next one. Question 12a. Factorize it completely. Okay, anybody needs help with this? Anybody? Okay, who got this correct? This one. So there are still some of you who get it wrong. Hopefully it is careless mistake, but this is what I tell some of my other students. To prevent careless mistake, write everything out separately. So we have 3 multiplied by p multiplied by p multiplied by q. That is my 3p squared q. Then I minus, instead of writing 12, I want to write it as 3 times 4, because there's a factor 3 over here already. Then we've got p and q. Then plus 3 multiplied by 2, p, q, and q. So now I wrote everything out. Then I'm going to find common factors. Is there a 3 everywhere? Have. 3, 3, 3. So go on to the next step, and you write the 3 over here. Then what else is common? Is there a p everywhere? Yeah, there is. There is 1p, 1p, and 1p over here. Put it here. 3p. Any more p's? No, this one doesn't have p. This one also doesn't have p already. So we move on to q. Q, q, and q. Put a q outside. So these are the only 3 that are common. All of them have a 3pq, 3pq, 3pq. Next, you open the bracket, and you write down 1 is left. Only p is left. Write down p. Minus 4. Write it down. Plus 2q. Write it down. Done. Okay? Okay, now we have 4 terms. And you are supposed to factorize them. We have to group them in pairs. Choose 2 of them such that you have common factor. For example, 3at and 15bt. There's something in common, right? We've got a 3 and 15. You can extract out the 3. Over here. Then we've got t and t. So 3t. So what's left will be a plus 5b. So a plus 5b. The first 2 done. Let's move on to the next 2 terms. So the next 2 terms, 10yb, 2ay. Y is definitely common. 2 is also common. Let's put it down as 2 times 5 times y times b minus 2a and y. So now I'm only interested in the next 2 terms, because I've already done the first 2 to give me 3t a plus 5b. Okay, so the next part, let's just focus over here. What is common? Highlight them. 2 and 2. Y and y. Okay, at this point you may stop and say, okay, these 2 are my common factors, therefore I will get 2y negative 5b minus a. This is what you may have on the right hand side. Whereas on the left hand side we had 3t a plus 5b. So this becomes a plus. Then you remember, by doing this, we are supposed to get common factors again. But 3t is not the same as 2y. A plus 5b is not the same as minus 5b minus a. That's where you need to recognize that we can actually factorize out the negative sign. Remember, we are always taking out whatever is common. We are factorizing whatever is common. There was another negative sign. Here. We could have extracted that out. Put it over here. Then we are left with positive 5. Positive 5 times b plus a. No more negative, so it becomes plus a. So now we compare a plus 5b, a plus 5b. Now they are the same. And I can factorize them out again. So the next line will be a plus 5b. After I factorize them out, we are left with 3t minus 2y. I think this will come out also. Plus, this kind of sign change will come out also. They are not going to be so nice to you. I give you straight away 5b plus a. Most likely you will need to change the sign. Okay, and this is the common mistake. When you factorize out negative 2y. See the factorizing of negative 2y? We are supposed to end up with 5b plus a. But what happens is that students tend to put 5b minus a. They only changed one sign, they didn't change the other sign. Then they are stuck. Because there's nothing to factorize. Nothing in common already. When you reach this point, you have to realize that something wrong already. Because we are supposed to be able to factorize it into this way. So when you are here, if this happens to you, know that it's wrong. You have to know it, and you have to find the mistake. Finding the mistake doesn't mean that, if only this is a plus, I just put a plus lah. That's not finding a mistake. You're not learning if you do this. You have to know what went wrong. Okay, can I move on? Okay, let's do some. Okay, wait. You all are saying that you haven't learned this, right? Haven't learned the greater than, less than, equal to. Okay, then you can skip this question, but I'll just talk to you about this, just to let you know what's happening over here, because it's not difficult lah. Now x is between negative 3 and 3. X is greater than negative 3, and it is an integer, so x could be negative 2, negative 1, 0, 1, 2. These are the possible x values. You all agree? What about y? Y could be negative 9, negative 8, negative 7, so on and so forth until 1, 2, 3, 4, and 5. So notice the difference in our symbol. This doesn't have an equal sign at the bottom, whereas this has. So our y value can include negative 9, it can include 5. But our x value cannot include negative 3. It also cannot include 3. That's the difference in the sign. So now based on these values, find the greatest integer of x multiplied by y. You can choose any x, you can choose any y, but what is the largest possible x times y? So what do you think? Without looking at answer. What is the largest x times y you can form? Is it 2 times 5? Take the largest 2, take the largest 5. Take the largest x, take the largest y. You get 10. Very big number, right? But is there a bigger number that you can form? Yes? Yeah, how about negative 9 multiplied by negative 2? You get 18. Isn't that even bigger? Right? Okay, so we learned that, negative times negative actually gives me positive. Not too difficult, it's kind of like an IQ question. Okay, the next one, the smallest x squared minus y squared. I want the smallest x squared minus y squared. So, how do we obtain a smallest answer when you have something minus something? This is smallest. Okay, so try and follow the logic. For this to be the smallest, this x value has to be as small as possible. Do you agree? We want this to be as small as possible. Then for the answer to be the smallest, I want y squared to be as blank as possible. What do you think it is? You want y squared to be as small or as big as possible? You want it to be as big as possible. Yeah. Because when you have a very small number minus away a very big number, I am sure that the answer will be as small as possible. Okay, so what's the smallest x squared? What's the smallest possible x squared? What do you think? X squared means you square the number. Is it negative 2 times negative 2? No, negative 2 times negative 2, you get positive 4. How about negative 1 times negative 1? You get 1. How about 0 times 0? You get 0. That's the smallest already. Because when you continue, you get 1 again. Then you get 4. So this, as small as possible, x squared equals to 0. Now for y squared to be as big as possible, y squared equals to negative 9 squared, which is 81. As big as possible. So the smallest, x squared minus y squared equals to negative 81. Okay, so we'll stop here and I will see you again